So we're going to take a look at one final final proof of utilizing the axiomatic definitions or the procedural definitions to be able to prove one of these fundamental set laws. And this time we're proving the absorption law. For all sets A and B, we want to show that A intersect A union B is equal to A. We're going to find that this one's a little more abstract, particularly with case 2. Case 1's fairly easy, so let's go ahead and get to it. So let's start by saying let X be an element and let A and B be sets. Case 1, we're going to start with letting X be equal to the left-hand side. So we're going to say let X be an element of A intersect A union B. We're going to say by our procedural definition, this means that X is an element of A and X is an element of A or X is an element of B. Alright, so all we did was we just got rid of the intersect and union symbols. So here's our intersection, here's our union symbols. Now with an AND, that means that X is an element of both of these sets. So X is an element of A and X is an element of A or X is an element of B. So we can pick either one. Okay, so we can say since X is an element of both sets, and I'll write out is an element. So we're going to say since X is an element of both sets, we can use either. Or we could use both. I'll just put in parentheses, or both. Okay. Hence, X is an element of A. And we're done. Because that's exactly what we needed to prove. Okay, so we needed to prove that X was indeed an element of A, and we've done that. Okay, so hence we can say A intersect A union B is a subset of A. Right? That's the very definition of that. All right, so that's case 1. Case 1 is pretty straightforward. Case 2 not so straightforward. All right, so case 2, and here's why it's not straightforward. So now we're going to start by letting X be an element of the right-hand side, and the right-hand side is A. All right, so we're going to say let X be an element of A, and here's why it's tricky. There's no fundamental procedural definition. There's nothing you can do with the laws of logic. We just have A. Right? However, what we can do is we can say that X is an element of A or any other set. Okay, so by disjunction, X is an element of A or any other set. Okay, now that only works for or. Okay, that does not work for and. Okay, and we just have to strategically pick the set that we want. Well, if we go back up, at some point we are going to need A union B, A or B. So let's just say B. Okay. So we can say hence X is an element of A or X is an element of B. All right. Now check this out. Remember initially we said X is an element of A and also X is now an element of A or B. All right, so thus X is an element of A and X is an element of A or X is an element of B. And I believe that's exactly what we need to be able to utilize our procedural definition. All right, so again, case 2 is very abstract. So if you didn't get it through this time, what I would suggest is go back through, watch the video again. If you still have some questions, email me. But the most important part is for us to be able to make sure that we understand the OR statement. All right, so let's finish this off. And to finish it off, we're going to say by procedural definition, we can say that X is an element of A intersect, actually let me go to another new line with this. So by our procedural definition, X is an element of A intersect A union B. And then thus, we can say A intersect A union B is a subset, or I'm sorry, the other way around, excuse me. We could say that A is a subset of A intersect A union B. And then finally, by case 1 and case 2, we could say that A intersect A union B is going to be equal to A. So A intersect A union B is equal to A. All right, so this one's a little bit more abstract again, so I would suggest you guys watch it a few times just to make sure that you understand the process of this.